All right. So, hope everyone had a good weekend. Spring break is in 2 weeks, so we get a nice little break in 2 weeks. So, last session we didn't get to do it. So this session I decided, okay, we might as well open up with it. So some people were curious as to what happens if you delete the entire file system. So you don't need to worry about what this command does. It's called Docker. You can think of it as like a segregated or sandbox kind of thing for now. We're not going to really learn this in this class. This might be something you learn later in your career. But Docker is a very helpful thing. And so I don't delete my entire file system on my laptop. I'm using Docker instead. You can think of it as like a virtual machine. So I just went into a Docker container that has Ubuntu or Linux, and some people were asking what happens if you do this. So we're going to find out. I haven't tried it. This is the first time I've ever tried it. So it's going to ask me for my password, which is just a temporary thing. Okay, so looks like there is actually a warning about this. But let's try another dangerous one. So sudo rm-rf .star. So, okay, so it seems like there's some smart things going on. Okay, so it says use no preserved root. So it seems like it is trying to make it a little bit harder. So let's see if I can force it to do some things. Preserve root. Oh, there it goes. So it looks like it does have some safety things in, but oh, now we can't even do ls, so it deleted ls. There's no clear command even. There's no man command. You just deleted all your commands. So now I hope I can even use exit. Let's see. Oh, I can use exit, so I didn't delete exit. So good. All right, so that's what happens. You can't do it because you don't have super user access or admin access. At least you can't do it on the Linux labs. Now, if you do this command in the Linux labs, you'll most likely delete your own profile because you do have access to your profile or your stuff. So it won't cause damage to anyone else, but it will probably cause damage to you. So, yeah. Maybe. So it deleted a lot of the programs that are installed. So if you reinstalled them or found a way of restoring them, then yes. But the problem is even the default, like it looked like it even deleted ls. It might not even allow you to do cd anymore. So a lot of the things you need to actually restore it are not there anymore. So I doubt you would be able to do it. You might be able to inject machine code or something like that, but you would have to do it from outside somehow, because I don't know exactly how you would do it inside, because you don't have the tools in it anymore. So, but yeah, so that's what happens. So yeah, you'll brick your machine, basically, is what I'm saying, if you do this. So be careful. And a lot of people have asked what sudo does. So I'm going to teach you this. So now I'm outside of that segregated system. It's gone. I deleted it. It's gone. So, but what sudo does, let me just do this. So this command, I'm just going to put quotes around it for now. So what sudo or sudo, whichever you want to call it, it stands for super user do. And this just allows you to run things as admin. So if you're on Windows, it pops up with the user account control and it says, are you sure you want to install this? That's their way of doing admin credentials. Linux does sudo in the command line. And once you enter your admin credentials, it'll let you install stuff and whatnot. We'll see this later in the semester, how to install Linux and everything. Or if you want to learn how to do it now, we can talk after class or come to my office hours. So, okay. So without further ado, let's get into today's lecture. So, updates. Quiz 01 should be up this week, so you'll have your grades back. If you ever, I haven't announced it yet, but if you ever want your quiz back, come to my office hours, try to email me in advance so that I can have it ready for you to drop by and see it if you have any questions. I will post the solutions to Quiz 01 if I haven't already. I might have done it. If I haven't, then I'll upload them. So a couple things about grading questions. So if you ever have questions about grading, you can email me or the TAs. If you email the TAs, they're most likely going to CC me to confirm with me. Or you can come to my office hours and I'll try to address any grading questions. We cannot be specific over email about grading questions. There's a law called FERPA, very much like HIPAA, that protects your grades. And we can't send specific details about your grades over email. So if we're being very ambiguous or vague, that's why over email. We're not allowed to do this. So we can say, hey, we've updated your grade, but we can't say anything specific about it. So yeah, we have to protect your privacy and stuff like that for grades, because it's no longer your parents get access or rights to your grades anymore. Okay, so if you have any grading questions, come into my office hours. So office hours, at least for me, I don't know about y'all, but at least for me, it would be nicer to have office hours after this class. So I usually have them on Mondays and Fridays from noon to 2, but I'm going to reschedule at least Monday's office hours after the class. So directly after this class, after it ends, I'll have office hours. Does that work for people? Is there anyone extremely against that? Okay. So if you can't make my office hours, you can always email me and make an appointment with me, and I'll try to be flexible and we can figure something out. So please use my office hours. Right now, we're still getting into things, but starting this week and next week and stuff, things are going to start getting a little bit more challenging. So take advantage of the office hours. Couple other things. You are responsible for your submission. So I've had a couple students, and it always happens. I get it. I did it as an undergrad. It sucks. But you're responsible for ensuring that you submit your lab correctly. So every time after you submit a lab, you should make sure that you go back there and make sure you actually submitted it. And make sure you submit the right file. So I had a couple people that either forgot or whatnot. That's okay. I'll give you one chance to give me a timestamp of the thing and then us grade it. But after that one chance, you got to be responsible a little bit. So, okay. Quiz 2 this week. So please show up to lab. It will mainly be a quiz and a very, very quick lab. I'm probably going to just say, download this file, run these commands, we do the quiz, you're done, kind of thing. So that way it's simple. Homework 01 is assigned and due next Monday. Last time I checked, there's about 14 people that have done it. So try to start as early as possible, because there's a lot of room for error. And if you wait till the night of, I'm not going to respond back at 10 or 8 p.m. answering questions from 100 students, right? So please start early. Please start this week if you can. Okay. Yep. And so again, I want to emphasize, labs are meant for you to practice. They're only there to help you. If you don't do the labs, or you just don't put any effort into the lab, it's only hurting you. I don't care what you put on that piece of the thing that you submit. You can, they're not that important. Just submit something to show me that you tried. I know that it seems like it's a lot of work in the class to do the labs, but don't be a perfectionist. Don't say, I've got to do the lab exactly perfectly every single time, because it's going to be overburdensome for you to do it. So just submit something by Friday night, and you literally get 15 out of 15. So if you don't, email me. I can talk with the TAs to adjust that expectation. But yeah, you don't have to finish it to 100% or perfectly every single time. I just want you to practice. So yeah. Okay, so up until now, we can navigate the command line, right? Unless you delete the root. We've learned a couple commands. Last week, we learned how to expand those commands. And then we touched on Git. That's your homework. If you haven't started, your homework is using Git. Know how to edit files, command lines. We wrote some scripts in the last couple weeks. And now we're going to start some new stuff. So what does -R stand for? Recursive. Yep. So if you do rm-r, that stands for recursive. -f. What does -f stand for? What? Force. Can also be file. So it's not always consistent between each command. It can be force, it can be file, it can be other things. What does -v typically stand for? What? What now? Verbose. Yep. So yeah, those are a couple options that you can remember and what they stand for. Okay, so quick thing about options. If I ask you on the quiz, what is an option? What do you say? What is an option? So an option is just simply a flag, something starting with a dash, that expands functionality. So if I ask you on the quiz this week, what is an option, or what is the difference between options and arguments? Well, options expand functionality of the command. It gives you other options into what to do with the command. But an option is also an argument. So an argument can be an option, but not all options are, So anyway, what I want you to say on options is just options expand functionality. Arguments can be files, they can be options, they can be anything. So what I mean by they're kind of interchangeable a little bit, that options are arguments, is that indexing thing that we talked about. So each time you have a different argument for your command or program, it's indexed 0 to 1. So yeah, I might ask you a question. Here's a command. Tell me what index they're at. So if I give you ls-a, what is at index 0? ls. If I get what is at index 1? -a. Yeah, exactly. So yeah. Okay. So what we're going to go over today is standard in, standard out, standard error. Everyone's favorite topic with the programming languages. So what we're going to do with these is called redirection. And there's several different operators. Those are most of them. And then we're going to learn about pipes. And we're going to learn about other special symbols. So what is redirection? So redirection just simply changes where data goes. So when I say redirect something, it's just taking data from one place to another. And there's a ton of different operators for this in Bash. There's mainly 4 for redirection, which we'll go over in a second. So up until now, we've been using the commands in their default format. They all kind of default to the terminal. So when you run a command, the output goes straight to the terminal. It doesn't go to a file or whatnot. So we're going to learn how to take that output and put it somewhere else. And the same thing goes for input. Instead of inputting something into a command directly, we can use redirection to input from a file or something. So, all right. So think of, when I say redirection, think about sending and receiving data between commands. Okay, you'll see what I'm talking about in a second. So, like I said, by default, everything starts in the terminal. So standard in, standard error, standard out, all default to the terminal. All right, so how do we do standard out? So you have 2 main operators here for standard out, and standard error, you'll see that in a second as well. So you have one single greater than symbol or angle bracket to the right, and then you have 2 angle brackets to the right. So you could also be more specific and say 1 angle bracket and 1 double angle bracket right here, but this just 1 just stands for standard out. So yeah, greater than symbol, 1 single angle bracket overwrites. So let's do it. If I take echo hello CSCE 215 and then do test.txt, then now I have this test.txt file. So when I redirected it, it actually created the file. So you don't have to do touch. You can just redirect something. It will automatically create the file for you. So now if we do cat test.txt, we have hello CSCE 215. All right. So now if I do echo goodbye to test.txt, again, we still have that file. Didn't change anything about what the file looks like on the outside, but if we look at the contents using cat, now hello CSCE 215 is not there anymore. It overwrote. So when you use the single angle bracket to the right here, this overwrites any data that's inside of a file. So if you have something in the file that you want to keep, you should not overwrite it. You should not use the single angle bracket. Instead, what you probably want to use is this append operator. So that's 2 angle brackets to the right. So don't get them mixed up, because you'll accidentally overwrite something and you'll never be able to get it back. There is no version control here unless you're using some kind of Git. The reason we're learning Git is so that you can maybe avoid accidentally overwriting something and deleting something permanently. If you have version control in place, then you won't have this issue of you accidentally overwrote something and not be able to get back. So yeah, so now let's see what the double arrow does. So if we do echo, so remember we have cat test.txt, says goodbye. If I do echo CSCE 215 and then do 2 brackets to the right, then I say test.txt. If I do cat test.txt again, now it put it 1 line down. Yeah.
Does the spacing come automatically because it's on a different line? It's just automatic?
Yeah. So every time you append, it adds it to a brand new line. It appends it to the end of the file. So it doesn't add it at the beginning. It doesn't add it truncated to the left or anything. It just puts it on a brand new line. Yeah.
If you add 2 different lines in the same command, when you're trying to append it?
Yeah. Like add 2 different statements on each 2 lines. Yeah. So this varies from shell to shell. So I've mentioned it before, there are tons of different shells. There's bash, there's Z shell, there's fish, there's tons of different shells. Mac uses Z shell, so it has one way of doing things. The Linux labs are using bash, which is a different shell. So they're a little bit separate. So if you're using your Mac to do your assignment, some things might work on your Mac that don't work on the Linux labs and vice versa. But if I do something like this, echo CSCE 250, let's do something different, robot. And then if I add the new line character, which is \n, and then beep, let's see if it does it. Because like I said, different shells are different, and I typically just do 2 echo statements to avoid this issue in general. So let's try it. Test.txt. I do cat test.txt. There's 2 lines. So if you add the new line character, at least in Z shell, it works. Now, if I remoted into the Linux labs and did the same statement, it would probably not work because it handles new lines differently with echo. So you kind of have to try things on the shell that you're working with to make sure they work correctly. Unfortunately, I mean, there is some standardization to this stuff. It's, I think, called POSIX shells or POSIX compliant shells. It's not always, not everything's POSIX compliant and whatnot. So you're going to have different shells that do different things different ways. You'll just kind of have to try it as you go. So yeah, if you do the new line character, this \n, it'll add it on 2 different lines. So yeah. All right, so I've had some examples here. You can look over it if you want to study. There's a bunch of them. So one in general that I want you to notice is these 2 lines at the bottom. You have bash script.sh, and then the output of this bash script.sh, at least the standard output, that is, goes to log.out. So if I write a script, so if I do vim script.sh, and then I do my shebang, again, don't worry about what this is. We'll go over it next week probably. And then I do echo hello world, and then do pwd maybe. And then I do bash script.sh. There's your bash script.sh output. Let me move it up a little bit. So bash script.sh. So this is what it prints, right? We're used to that. But now if we take bash script.sh and we want to take that output and put it in a file, so up until now you've been copying and pasting the output. Instead of doing that, now we can just redirect to out.log or something like this. And then now if we look inside of out.log, there's our output. So instead of putting it in the terminal and printing to the terminal standard out, we took standard out and redirected it into a file. So it's like file I/O. If you're familiar with your languages, your like Java, C++, Python, you always have to write file I/O to write to a file. Instead of doing that, you can just do standard out. You can print the standard out with your program and then do it in bash. You can just redirect it. This is what I do sometimes. So instead of writing the whole file I/O in your program, you can just do this. So a little bit easier. Okay, so that's redirecting standard out. So you have one angle bracket, two angle brackets, and then you have one. So this one right here, we'll see it in the next slide. This one just refers to standard out. There's another thing called standard error. So when we want to do standard error, we have to be a little bit more specific. So now we have 2. So 2 refers to standard error. So if you put a 2 in front of your angle bracket, now you're redirecting standard error. So this is useful because you can separate the 2. You can separate standard out and standard error, and you can put the standard error in a certain file, and then you put standard out in a different file. So, all right, so only redirect standard error. All right, here's some examples. So a lot of you saw last week that when we do wget, the command, and you do that whole bash whatever and you're redirecting, that little redirection operator we had in the last lab, the reason it still printed something, that whole download process, was because that was standard error. So if we do this wget thing, you used to get this with your bash command, right? Looks familiar? So you got this message. Well, this stream of text right here goes to standard error. So even if we did something like this, log.out or something, it still prints something, right? But that's because it's standard error. So if we want to redirect this message right here, that's standard error, then instead of doing just a single angle bracket, we do 2 in front of it. So now it doesn't show anything. We're waiting on it to download, and it's writing to the log to the file. It takes a second because it's a lot of data. Come on. Okay, the network might be acting up now. Shouldn't take that long. All right, so let's try that again. There we go. So now if we look at log.out, here's that message, or that whole like progress bar kind of thing. It's not skipping over, it's putting the error message inside of a file. So instead of doing this wget thing and letting it print the message to the terminal like this, we're printing it inside of a file. We're writing it inside of a file. So that little 2 angle bracket is actually putting all this error, this message and everything inside of a file. All right. So yeah. So if I wanted to maybe redirect both at the same time, how do I do it? Well, if you want to take both your standard output and standard error, yeah. What message? Yeah. So it also captures warnings, and I mean, not everything is that is in the standard error stream is actually errors. It's just printing out a log of what's going on. So the reason you have 2 different streams is standard out is more for like output, right? The results or whatnot. Standard error is for logging. So if you want to have results and logging at the same time, you can separate them into 2 different streams, so standard out, standard error, and then you can have one go to one file and one go to the other. So if we want to do that, for example, I could do wget, and then I can do 1 angle bracket, and this is called out.log. And then if I want to do standard error, then I can do error.log. And that's perfectly valid. So now I have 2 different files, with one with the output of the script, the results, and then one with the error or the warning or the log messages. So you can kind of separate the 2. And you can change which stream it goes to inside the script, or whatever you're running. You just have to kind of program it that way. Yeah. So it's just two different streams. You have two different ways of outputting stuff, messages. You have standard error for like warnings, messages, logs, whatnot. And then standard out is just for anything else. So just two different ways of printing something. They're two different streams. And the reason is so that you can separate the two like this. So you could have them all as one stream, but then you don't get the flexibility of having 2 or 3 different streams. Okay. So if you want to do both at the same time to one file, you can do this long verbose thing. I don't like this. This is hard to remember. I never remember 2 angle bracket ampersand 1. Instead, I use the shorthand, which captures both of them. So it's just whatever program you're running that does output, and then an ampersand angle bracket. So with this command right here, we did 2 separate files. But if you want all your standard error and standard output to go into one file, then you can just do this. You do wget, and then ampersand 1, or ampersand angle bracket, and then log.log or something like that. You do this, all your standard error and standard output goes into one file. So, yeah. Any questions on that? So you got 2 different ways of printing a message, per se. You've got one way is standard output, another way is standard error. And they kind of correspond to whatever you want to do. So nothing's keeping you from writing to standard error for no reason. Like I said, they're just there for your usage. Okay. So just like we've seen many times in Linux, there's tons of different correct ways of doing things. Just because I put this way up here doesn't mean it's the only way. I try to do the shortest or the more simple one. So, okay, redirecting standard in. So when I say standard input, it's like asking the user for input. Or it's trying to take a file or some kind of input and put it into a program. So that's one angle bracket to the left, or a less than symbol. So left angle bracket, usually passing the contents of a file to a command. So you have some options here. You can take a file and input it, or you can take the output of a command and put it inside. I really don't honestly use this much, but you can. So one example is we can do word count -L. Let's do ls first. So let's say error, let's cat error.log. Okay, so if I want to count the number of lines in this error.log file, I can take word count -L and then put a left angle bracket and then do error.log. And if I enter down a little bit, there it goes. If I do this angle bracket like this, it counts the number of lines, which is 495. Alternatively, that's kind of useless because you could just as easily do word count -L error.log. So like I said, this like whole left angle bracket thing is not going to necessarily always be used. I used the output redirection more than I do input redirection. All right. So what about the 2 angle brackets to the left? So we have angle bracket to the right. We got 2 angle brackets to the right. We've got 1 to the left. What about 2 to the left, right? Well, I'm never going to expect you to know this because I've never used it, except for copying, pasting commands occasionally. So it's called the here document, and it just allows interactive input. So here's an example. So if you want to do WC, like a command, and then you do this. So EOF stands for end of file. Oh, wrong way. I got to do 2, like that. It's going to enter you down to another line right here. And it's expecting you to put some input. So hello world CSCE 215 beep. Keep going as long as we want, but as soon as we do this EOF for end of file, it terminates and actually takes all this input right here and puts it into word count. So It's there if you want to use it. If you find a special use case of using it, I don't really expect you to know this one, but it's there. Okay. So, yeah. All right, so pipes. This is the one we'll use a lot, and I'll expect you to know how to use it a lot. This is where you start getting really complex with your scripting, with your commands and everything. So what a pipe does, so if you've never heard of a pipe, it's that vertical line on your keyboard. If you hit Shift backslash, it's below the delete or backspace button. If you hit that, it'll print this vertical line. It's called a pipe. So what this does is allows you to chain commands together, but it does it in a special way. So what it allows you to do is take the input of one command, the first command, and then you do a pipe, and then it passes the output of that command as the input of the next one. So what does that mean? Well, let's show you. Well, let's do the visual demo first. So I'm going to maximize this. So if we look at the examples, if we take ls and then pipe it into wc-l, what it's going to do is print the ls output. It's going to pass that into word count. So it'll give you however many lines or words are inside of ls, the output of the ls command. So this is not very helpful. Okay, so think of a Mario pipe, right? So I tried to make this a little bit fun. So take this command, cat cities.txt pipe wc-l. So first it runs cat cities.txt. So assume that cities.txt has cities of the US or South Carolina. So it first runs this, and it outputs that. Outputs some cities, right? Charleston, Columbia, Greenville, Spartanburg, whatever. All right, so once it executes that, it takes this output right here, puts it into word count, -l. And what that outputs is it starts counting the number of lines. So what the outputs at the end result is 4, right? So it takes the output of this cat cities.txt, feeds it into the second command, and then outputs 4. Because it counts the number of cities. Right? Does that make sense? All right, so not too bad. Takes the output of one, passes it to another.
At the end, will it only display 4 in the terminal, or will it display both?
4.
It will
It'll literally just be 4.
Okay.
Yep. All right, so let's do an example. So remember last lab, we had this big chunk of data, and I told you to get the first 23 lines and the last 34. What if you want to get 23 through 25? All right, there's not really a command, at least I've taught you, that will be able to do that. There might be another command that you can use this, but you can combine head and tail to get what you want. So let's print our mnist condensed. So all that data, remember? So if we want to maybe do this and get something between the top of the file and the end of the file, we can do head-11. So that gets the first 11 lines. And then I pass in the file name, mnist condensed. And then I've piped those 11 lines to the tail command. So let's do tail-n 3, and then press enter. So in theory, what this did is it captured 11, 12, or 11, 10, and 9, right? So those 3 lines got captured. So we took the first 11, got the last 3 of that. Does that make sense? So we got 9, 10, and 11, those 3 lines. Yeah. So this command, so first we get the first 11 lines, then we take the last 3 of that. There you go. So now you're getting something between.
So if you wanted to get something between 20 through 50, you'll have 50, or
Head 50, and pipe that into, tail 20. Exactly. Yep. So yeah, so now we can start doing more complex things. And this is a simple example. But later in the semester, when we get to grep, you can chain commands together to search things more. You can narrow things down a lot. So for now, we'll kind of use the pipe in a naive way, but we're going to start building upon it and doing some really fun stuff. Okay, so comments. Most of you know this already. Comments use a pound symbol, just a single pound symbol. So in your scripts, if you want to write what you're doing as you go and comment and document like the good programmers and scripters you are, you put pound symbols, you write what you want beside the pound symbol to the right of it. So just a quick thing, the pound symbol is different from the pound exclamation symbol. So when inside of your script, when you do that pound exclamation point, it's doing something different. It's telling the shell what program to use to run your script. So when you type this, it's doing something different. It's just a comment, right? But if you do this at the top of your file, then it's something different. So don't think of those two as the same. So pound exclamation is different from just a comment. And like I said, we'll go into it probably next week, what exactly it does. All right, so another thing. So I'm going to go ahead and put this disclaimer. Do not, you'll see this online a lot. You'll see these two ampersand symbols, how to do two things at once or whatnot. When you separate commands by the two ampersands, it's doing it like mutually exclusive way. It's completely independent. So like if I wanted to do echo this, like I did earlier, echo robot beep on two different lines, and I wanted to count how many lines there are, like this, gets me 2 because new line character. If I try to do the same thing but do ampersands instead, it's not the same thing because now echo robot /n beep is running by itself, but then word count -l is running by itself too. What? There's nothing to count because they're two completely different commands. So all this allows you to do is run 2 or more different commands on the same line. It doesn't mean that they're working together in any way. They're completely independent of one another. If you want them to work together, that's when you use a pipe or redirection operators. You don't do this. So don't get pipe and the ampersands confused. So maybe if you're doing something like make directory temp, and then maybe ampersand touch temp test.txt, and then ampersand cd temp, you're doing 3 different things here. They're not working together. They're completely exclusive from one another. So you create a directory, then you create a file, and then you go into that directory. So if I press enter, now if I do pwd, I'm in temp. And if I do ls, there's test.txt. So the only benefit of these 2 ampersand symbols is to allow you to do more things in one line. That's the only thing. Okay, so don't get those 2 confused, please. Ampersands are not the same thing as pipe or redirection. All right, so some people saw the curly braces. Now we're going to actually go over what the curly braces do. So curly braces make your life easier. So I'm going to stay in this directory, so I'm going to delete test.txt. Say you want to create 26 different files named A through Z, right? So A through Z.txt or whatnot. So instead of doing touch A.txt, B.txt, and so on, and so on, and so on, instead you can do touch curly braces, A, and then you can do B, then you can do C. You could do this and do A through Z all the way there with commas between them, or you can do a range with 2 dots and then a Z. And then just end with .txt. So what this does is says, take A, make A.txt, make B.txt, make C.txt. So let's press enter and see what it does. So now we have 26 separate files, A through Z. And we just created them all in one little command. So this is useful already, because if you're like trying to sort cities and states and whatnot and put them in their separate files, you can create the 26 different files at once and then iterate through them and place the contents that need to be in there with your script. So instead of having to do touch, 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 you can just do touch a dot dot z with curly braces around it. You're done. All right. You can do the same thing with make directory. So we want to make directories 0 through, let's do an extreme example, 500. I hope this doesn't hurt my computer. Let's put dir. Let's put a prefix dir. Dir 1, dir 2, dir 3, all the way to dir 500. So if I do this, look at how fast that was. There's all your directories. Right? There's 500. No, so the way things are sorted when you do ls, you can change this, by the way, is it goes off of characters. So it goes left to right with the characters. So you're going to have dir 0, dir 1, dir 100, dir 101, dir 102. It goes by each character in order. Now, if you want to sort them, you can pipe into sort. And now we have something a little bit better. Not exactly what we want, but we've got something a little bit better. Right. Now, if we had done 0, 0 through this, then it would be better. So if we did, this is where you start doing this. Got to be a little bit careful. rm-rf star. I just deleted everything in that directory. We'll learn about the star in a second. If I did make directory this, let's see if it works. There. So now we have what we want. We have those zeros at the beginning. So we have dir 0, 0, 0, dir 0, 0, 1, 0, 2, and so on. So, yeah. Makes it easy. All right, so that's what curly braces do. The only disclaimer I will say about this is make sure you don't put spaces. So some of you found this online, but you put spaces between the commas and everything, and that messes it up. So if I show you, let me get rid of all these directories. All right, so if I do make directory dir a, comma, space B, comma, space C, and then end it like that, well, my terminal's telling me, hey, you're doing something wrong already. But if we do this, it doesn't do it correctly on my terminal. Now in the lab, it might let you do this, right? So if we try maybe putting quotation marks around it, then that's obviously going to make that directory name. So don't put spaces. When you're doing curly braces, don't put your spaces. Just delimit them with commas or do the dot dot for the range. So don't get those kind of mixed up. Oh, and I got to do rm-r. There. Okay, so that's curly braces. We'll go over what's called regex. And I'll go ahead and give you just a quick disclaimer. This is not regex. All right, so when we get to regular expressions or regex, this is not the same thing as regular expressions. So just keep that in mind. All right, same thing with this slide. Not the same as regex. There's a little bit of overlap here, but don't think of them the same way. These are two different ideas. All right, so now you have wildcards. So wildcards allow you to do things a little bit quicker. So when I was doing rm-rf star, star refers to 0 or more characters to match. So any character, A through Z, symbols, whatever, letters, numbers, whatever. So it stands for 0 or more characters. And then the question mark is just any single character. So let's see where we can use this. All right. So if I do make directory dir 1 dot dot 50. All right, so now we have 50 directories. If I want to delete everything that has a one digit number, then I can do this. rm-r dir question mark. So that question mark only stands for one character. Any character, doesn't matter what they are. In this case, it will be 1 digit. But that question mark only means one. So if I want to delete all the single digit directories, I press enter. And now all the single-digit directories are gone. Right? So question mark is just one single character. It can be any of the characters, but it's only one. All right? And I could do this other things like this. And if I wanted to do something, maybe delete all directories in the 20s, then I could do dir2 question mark. Press enter. Now all the 20s are gone. Right? So you can be a little bit specific with this, but you can do a lot of things at once, is the purpose of this. All right? Yeah.
If you want to delete a specific directory, would you just type out the whole thing?
Yeah. Yeah. And I mean, just like we've learned, you can also do dir1, dir2. You can like put as many as you want in here, and it will delete all of them, like this. Okay. So what about the star? Well, I've shown some of you this already. So with this star, if I want to delete all the rest of these, right? All I have to do is do rm-r star. I could also alternatively do dir star. So that star is just acting as a placeholder for anything, 0 or more times. Now remember, it starts with 0, not 1. It's 0 or more times. So it could be, so if we had a directory named dir, just dir, like that, then if I did rm-rf dir whatever number or whatnot, then it wouldn't get rid of this dir, right? Or if I just did question mark here, or question, then it still wouldn't get rid of this dir number, or dir directory, right? So if I want to get rid of everything, including the dir directory by itself that doesn't have anything after it, I do the star. And now they're all gone. So it deleted just the dir directory, but it also deleted any directories that had anything after dir. Does that make sense? So 0 or more, not 1 or more. Okay, so that's the star. All right, so question marks. So question marks just allow you to forgo these like wildcards. So you have that question mark, you have the asterisk, but if you want to take quotations, you can put quotations around it to make it more literal and escape those wildcard characters. So if I do, if I make directory and then do star, or let's do star dot, just star test, or let's do touch star.txt. If you do that, then it's not going to create one. I don't know why you would want to name something star.txt, but if you wanted to, it's not going to allow you to do it without quotations. So if you actually want to make a real file, you have to put quotations around it. So now we have a star.txt file. If we put quotations around it, it prevents those wildcards from being expanded. So that star inside of quotation no longer means 0 or more, it means a literal star. Okay, so lastly, escape characters. So if you ever do like print something, like a file, or you do an echo statement or whatnot, and you want literal characters instead of it escaping them or expanding them or something, you have to do an escape character. So let's say we want to do echo robot, right? If we do this, it just prints robot. But say we want the quotation marks. We actually want the quotation marks. Well, the way you do that is you put backslashes in front of them. So now, when we do the backslash quotation mark, it actually prints the quotation marks this time. So keep that in mind. Throughout the semester, if you print something and you want quotation marks or a certain symbol, certain symbols mean certain things in Linux. So you have to sometimes escape them with a backslash. We'll see some more of these later. But yeah, so be prepared for the quiz.